In 2028, Elon Musk plans something far more dangerous than anyone expected. A bold attempt to turn a single Starship into humanity's first real off-world home, right on the rim of Shackleton Crater, where sunlight barely fades and frozen water could power entire missions. But the most shocking part isn't the location. It's how SpaceX plans to build Moonbase Alpha by tipping over the world's biggest rocket and transforming it into a permanent lunar habitat. To understand how SpaceX plans to build a functioning lunar outpost using just one Starship, we need to look at the core idea driving this entire mission, an idea so unconventional that at first glance, it sounds impossible. According to SpaceX's official mission outline, cargo flights to the lunar surface are expected to begin in 2028, marking the first major step toward turning Moonbase Alpha from concept to reality. But what truly sets this plan apart is Musk's refusal to follow the traditional blueprint for a moon base. Instead of delivering prefabricated structures, landing modules, or inflatable habitats, SpaceX intends to do something radically simpler and far more ambitious. The guiding principle is straightforward. The best lunar base is the one you don't have to build from scratch. In other words, if you already have a massive, pressurized, fully equipped spacecraft capable of supporting human life, why not turn that into the base itself? This is the philosophy behind the base without a base concept. A Starship designed for lunar operations isn't just a transport vehicle, it's the habitat, the laboratory, the workshop, and the storage unit all at once. Rather than being a disposable rocket destined to be abandoned after landing, it becomes the foundation of a permanent lunar presence. This approach dramatically reduces cost, complexity, and the number of missions required to establish a functioning outpost. And it's not just clever, it's scalable. Historically, the International Space Station cost around $150 billion to construct, with dozens of launches required to assemble its modules piece by piece. In contrast, Skylab, America's first space station, was created by repurposing a Saturn V rocket's upper stage at a fraction of that cost. SpaceX intends to replicate that same level of efficiency, but on a scale never attempted before. The lunar Starship itself has been redesigned for permanence. Without wings, without a heat shield, and without the systems needed to survive re-entry, these ships aren't coming home. They are meant to live out their entire existence on or around the moon. Painted white for thermal stability and aesthetics, each Starship arrives already containing about 1,000 cubic meters of pressurized volume, more than any crewed spacecraft ever built. But that's only the beginning. After landing, SpaceX plans to convert the ship's enormous fuel tanks into additional living space, adding another 1,400 cubic meters. That more than doubles the interior volume available for astronauts. Bedrooms, workstations, laboratories, storage rooms, and environmental systems could all be expanded into the previously inaccessible sections of the rocket. Suddenly, a single Starship transforms into a sprawling lunar habitat with more room than the entire ISS modules combined. Even more astonishing is the economics behind it. With SpaceX targeting launch costs below $10 million per flight, this strategy creates the cheapest habitable space per cubic meter in human history. No inflatable domes, no multi-module construction, no decade-long assembly timelines, just a single spacecraft repurposed into a new kind of off-world home. But the boldest part of the plan is still ahead, because once Starship lands, SpaceX intends to do something that sounds reckless, yet unlocks the full potential of the design. They plan to tip it over. The moment Starship touches down on the lunar surface, the mission enters its most daring phase. one that sounds almost reckless until you understand the engineering behind it. Because to unlock the full interior volume of the world's biggest spacecraft, SpaceX plans to do the unthinkable, gently tipping a 100-ton lunar lander onto its side. It's a maneuver so bold that it initially seems like a setup for disaster, yet it is essential to transforming the vehicle into a true off-world habitat. When Starship is upright, most of its interior consists of massive, empty fuel tanks that extend deep below the crew section. Only the upper third is accessible living space. But once the rocket is laid horizontally, the entire 50-meter-long hull becomes usable. This single move turns what would be a tight vertical living stack into a spacious lunar habitat, more like a long, open-concept research module than a cramped spacecraft. The benefit is enormous. A base large enough to support science missions, engineering work, long-term habitation, and emergency shelters, all without launching separate station modules. But how do you tip over a vehicle taller than the Statue of Liberty without turning it into twisted metal? The process relies on physics, planning, and the moon's gentle gravity, 1/6 that of Earth's. Engineers begin by attaching heavy-duty cables to the top of Starship's nose, where structural stress is minimal. Once secured, 1 or 2 powerful lunar rovers move slowly away, using the cables like a giant lever to pull the ship downward. On Earth, this would require immense force and risk catastrophic collapse, but the moon's weaker gravity reduces the strain dramatically. Still, lunar dust presents a serious challenge. Its powder-like surface can behave like dry snow, light, slippery, and unpredictable. A single miscalculation could cause Starship to slide or rotate improperly, jeopardizing the entire mission. To prevent this, engineers first compact the landing area using controlled bursts from Starship's own thrusters. This creates a firm, stable platform similar to a landing pad. Only once the surface is safe do the rovers apply steady tension. Another method involves a massive electric winch anchored to something immovable, a buried steel spike, a large boulder, or even the landing leg of another Starship. The winch reels in the cable with slow, deliberate force until the craft gently leans over and eventually settles on its side. No sudden movements, no uncontrolled falls, just a carefully choreographed tilt that transforms the ship into a functional station. Once the rocket is horizontal, the real construction begins. Astronauts enter the now accessible interior and start stripping away unneeded rocket hardware, replacing it with a new deck running lengthwise through the ship. This creates a central hallway, dividing the space into upper living quarters and lower equipment bays. The transformation involves installing walls, lighting, insulation, plumbing, wiring, and life support infrastructure. Everything needed to turn a fuel tank into a working home. It's like converting a giant metal cylinder into a futuristic lunar loft. Expanding into the fuel tanks is the most labor-intensive part. It requires cutting through internal bulkheads, sealing them against leaks, and reinforcing the structure. Estimates suggest the full modification process could take around 165 workdays, with about 60 dedicated solely to tank conversions. Performing this in bulky pressurized suits, where each movement is slow and dust infiltrates everything, is an exhausting challenge. This is why robotic helpers, potentially Tesla bots, may take on the heaviest tasks, freeing astronauts for precision work and safety-critical operations. Little by little, Starship becomes more than a spacecraft. It becomes a doorway to the moon's future, a testbed for living beyond Earth. Transforming Starship into a functional habitat is only the beginning. A lunar base, no matter how innovative, is worthless without a stable and continuous source of power. And when it comes to the moon, power isn't just a utility, it's survival. Every system, from life support to communication to water extraction, depends entirely on reliable energy. That's why SpaceX chose one of the most valuable real estate locations in the entire solar system, the rim of Shackleton Crater. Shackleton's rim is one of the rare places on the moon where sunlight is nearly constant. Because of the moon's slight axial tilt, the sun hovers close to the horizon, casting long, low-angle rays that sweep across the crater's edge for most of the lunar year. While other regions endure 2-week-long nights that plunge temperatures to deadly lows, this ridge remains illuminated, offering a nearly uninterrupted power supply. For a base that depends on solar energy, this is priceless. Solar panels positioned along the rim would capture sunlight far more efficiently than they could on Earth. Without an atmosphere blocking or scattering light, the panels can produce between 300 and 400 watts per square meter, about 25% more than they would on the surface of our planet. Over time, arrays could stretch across the crater edge, delivering continuous energy to Starship habitats, rovers, 3D printers, and scientific instruments. It's the closest thing to a perpetual power grid the moon can offer, but even near constant sunlight isn't perfect. Shadows, equipment failures, and lunar dust could interrupt power generation. That's why backup systems are essential. One emerging idea comes from a company called Starcatcher, which is developing advanced lenses capable of concentrating sunlight and transmitting it over long distances. In theory, these systems could boost available power by up to a factor of 10 during critical operations. But they also introduce risk. Intense beams of focused light must be controlled with precision to avoid damaging equipment or endangering astronauts. With energy secured, the next challenge is expansion. Starship alone offers a huge amount of space, but not enough for longer missions envisioned under Artemis. That's where in situ construction comes in. Using 3D printers, astronauts could transform lunar regolith into additional modules, labs, storage units, or dedicated living quarters built right next to the converted Starship. These structures could link together into a growing network of habitats, forming a hybrid base that evolves with each mission. Little by little, the moon shifts from a destination to a place where humans can genuinely begin to stay. Even with power secured and Starship transformed into a livable habitat, one truth remains: surviving on the moon is not the same as living on it. A lunar base isn't just a scientific outpost. It must become a sanctuary against an environment that is actively trying to kill its occupants every minute of every day. And SpaceX's plan addresses this reality head-on with one of the most crucial phases of construction, turning the habitat into a bunker strong enough to withstand radiation, micrometeorites, and the harsh extremes of lunar weather. Cosmic radiation is relentless on the moon. Without a magnetic field or atmosphere, solar storms and galactic particles strike the surface unfiltered. Spending months exposed to that invisible assault would be deadly. The solution comes from the ground itself. Lunar regolith, a powdery, mineral-rich soil that can block radiation when piled thick enough. Engineers estimate that about 5 meters of regolith would be sufficient to shield the habitat and create a safe environment inside. The moon's own surface becomes its armor. To deploy this protective layer, astronauts or robotic assistants use a specialized piece of equipment, a telescoping lunar crane. Think of a long, articulated arm mounted on a rover, equipped with a shovel or clamshell bucket designed specifically for low-gravity excavation. It scoops regolith, rotates, and deposits it carefully over the Starship hull. Layer by layer, the structure disappears beneath a blanket of lunar soil until the once sleek spacecraft becomes an underground shelter. This process not only makes the habitat safer, it makes it quieter, thermally stable, and far more insulated from the moon's violent temperature swings. But shielding is only one part of building a long-term habitat. The next step is psychological sustainability. A spacecraft-turned-bunker can keep humans alive, but for missions lasting weeks or months, they must also feel human. SpaceX's interior layout addresses this by creating a single, continuous deck stretching the entire length of the hull. This design offers something rare in space habitats: open space. Storage compartments below the deck keep clutter out of sight, while the upper section provides headroom, lighting, and modular rooms that can shift with mission needs. Workstations, a galley, sanitation facilities, exercise equipment, and entertainment areas can all be arranged along the long corridor, turning a fuel tank into something that resembles a minimalist but livable apartment. Meanwhile, 3D-printed regolith structures expand the base beyond Starship itself. Using industrial printers, astronauts can convert lunar dust into solid blocks, arches, or pressurized shells. These printed modules could serve as laboratories, radiation storm shelters, storage areas, or even tourist accommodations in the future. The more structures that rise around the lunar starship, the more it becomes a true settlement rather than a temporary experiment. Over time, what begins as a single repurposed spacecraft evolves into an interconnected campus of habitats and workspaces. But perhaps the most groundbreaking aspect of the mission isn't the construction, it's the practice. Moonbase Alpha is not just a place to live, it's a laboratory for learning how to live away from Earth altogether. The challenges on the moon are harsher than those on Mars. No atmosphere, temperature extremes, dust like microscopic shards, and radiation levels that make sunscreen meaningless. If humanity can adapt here, then Mars becomes far more accessible. Every experiment, every construction method, and every survival strategy developed on the moon will carry over to future interplanetary missions. This includes in situ resource utilization, the cornerstone of sustainable space exploration. Lunar regolith contains oxygen locked inside its minerals. By heating and processing the soil, astronauts can release that oxygen for breathing or convert it into liquid oxygen fuel. This single capability changes everything. With local oxygen production, Starship could refuel for return trips or deep space missions. Suddenly, the moon becomes a stepping stone rather than a dead end. Bit by bit, Musk's vision unfolds. A place where humans don't just visit, but endure. Where machinery hums beneath a blanket of dust. Where astronauts wake up each morning on another world and look out windows half buried beneath the surface. Moonbase Alpha becomes more than a mission. It becomes a declaration that humanity is ready to begin its next era. Beneath the layers of engineering brilliance and architectural creativity, there is a deeper truth driving the vision behind Moonbase Alpha, one that goes far beyond powering rovers, printing habitats, or tipping over a spacecraft to create a home. The moon is not just a destination, it's a classroom, a testing ground, and humanity's first real chance to understand what it truly means to exist away from Earth. And for the first time in history, we're close to building a place where that understanding can finally begin. NASA's Artemis program is focused on returning humans to the lunar surface and proving that long-duration missions are possible. But Elon Musk aims even higher. In his view, repeating Apollo is not enough. Planting flags and collecting samples were extraordinary achievements, but they didn't teach us how to stay. They didn't teach us how to build, expand, innovate, repair, endure, or thrive in an environment that is brutally indifferent to human life. Moonbase Alpha changes that. It gives us a chance to live off-world long enough to learn real lessons we cannot learn from simulations, laboratories, or remote probes. And we must learn them because everything about the future of human exploration depends on mastering life beyond Earth. The challenges are monumental. Razor-sharp lunar dust threatens machinery and human lungs. Long nights and extreme cold test every system ever designed. Radiation levels punish unprotected habitats. Every mistake is amplified in the vacuum of space. Yet that harshness is exactly why the moon matters. If humanity can adapt here, then Mars becomes achievable. Deep space travel becomes imaginable. Multi-planetary life becomes more than a dream. It becomes a plan. This is where the vision reveals its true purpose. Moonbase Alpha isn't simply about surviving on the moon. It's about transforming our relationship with space. It's about proving that humans can build a foothold in the cosmos using local materials, renewable energy, and machines that evolve with each mission. It's about creating a legacy that future generations can expand upon. One regolith block, one printed module, one oxygen extraction system at a time. Because in the long arc of history, Earth will not be enough. Not forever. Our planet is precious, but it is vulnerable to time, to catastrophe, and to cosmic chance. Building a sanctuary on the moon is the first step toward ensuring that human civilization does not remain confined to a single world. And maybe that is why this 2028 plan feels dangerous, because it forces us to confront how small we are and how much larger we can become if we choose to take that next step. The moon is waiting. The tools are ready. The blueprint is unfolding. And if SpaceX succeeds, future generations will look back on this moment, the tipping of a Starship, the laying of Regolith, the first printed shelter, as the instant humanity began its journey outward. If you enjoyed exploring this vision of our future beyond Earth, don't forget to like this video, subscribe to the channel, and hit the notification bell so you never miss what's coming next. And tell me in the comments, do you believe Moonbase Alpha will actually happen by 2028? Or is this mission even more dangerous than it seems?